So when this inertial tensor subtract a scalar quantity times a identity matrix, because if you deal with the matrix operation, you have to subtract a matrix from a matrix. You cannot subtract a value from a matrix directly. We said this whole thing, and you take the determinant, should be 0. So that's the formulation in eigenvalue analysis. Now, I know that the formulation may look a little bit strange, but when we apply it to these numbers, you will see what I mean. First of all, we're going to see what is the determinant here. Determinant means 4 minus lambda, because this is a identity matrix, which means that it only has the values on the diagonal elements. So you only subtract only the diagonal terms by this lambda. And lambda we don't know, which is the value we're going to determine. So the element 1 for this determinant becomes 1 becomes 4 minus lambda. Element 1, 2 is just 2 because lambda only exists on the diagonal elements. So here we're going to have element 1, 2 is 2. Element 2, 1 is still 2. It's not affected because lambda, like I said, only exists on the diagonal elements. And this one here, element 2, 2, becomes 2 minus lambda. The determinant of this matrix must be 0. So how do we determine the determinant of a matrix? The determinant of the matrix is this element, element 1, 1, times element 2, 2, minus element 2, 1, times element, minus element 1, 2, times element 2, 1. So it's 1, 1 times 2, 2, minus 1, 2 times 2, 1. That is the determinant. So what does that mean here? It means we're going to have 4 minus lambda times 2 minus lambda minus 4 to be 0. Correct? And how do we find the values of lambda? Now from here, you know very well that we're going to use this equation. What do we call it? Quadratic equation. Right? This is a quadratic equation. And this result, of course, if you write it, this becomes 8 minus 6 lambda plus lambda squared minus 4 to be 0. Correct? And you can just write it like move this term in its order, becomes lambda squared minus 6 lambda. A minus 4 becomes plus 4 to be 0. Now, from this point, how do you find the values of lambda? How do you find the values of lambda?
Quadratic equation.
Yes, quadratic equation. And just quickly recall quadratic equation because you need it for your career. What is quadratic equation? Quadratic equation states this. Suppose you have this equation ax squared plus bx plus c to be 0. X equals to 2a, well actually, minus b, plus minus square root of b squared minus 4ac. The whole thing divided by 2a. So we have two roots here, the plus and the minus. Right, so this is quadratic equation, as we know. Therefore, in here, what is these coefficients? If you apply this quadratic equation to the condition we have here, and you simply just plug in a being what? 1, right? So what's the value of b? What will be the value of b here?
Negative 6.
Yes, negative 6. Please don't think that I just want to take the quantity, forgetting about the sign, because by definition, b is associated with a positive sign. So if you have minus 6, b should be negative 6. What about c? C is positive 4. And once you have the a, b, c, you plug it in. I trust you know how to find two values of lambda, right? Because here we're going to find two different values of lambda, lambda 1 and lambda 2. So if you do that, and then you're going to get two different lambdas. If you use plus, and this value becomes 5.236. If you use minus negative sign, and this actually becomes 0.76395. Now, we're going to call the smaller value to be the first value of lambda. So whatever you find it here, you can maybe determine this one here. Maybe some people like to use the positive sign, some prefer the negative sign. In any case, once you get the values here, choose the smallest value as the first lambda. So we're going to call this one lambda 1 and the other one lambda 2. Right? Now, they are what? They are the principal values. So, which one means what? Which means that the IXX or the IX prime is 0.76395 and IY prime is 5.236. So they are the principal axis here. Of course, if you like to call, if you like to switch these two, mathematically, in terms of the finding the result, it will still give you the same result, because that simply means that you just choose to call X prime, Y prime, and vice versa. So that doesn't really change the whole thing. It's just about your definition of your axis. So if you think that, how do I know I have to do this? You don't have to memorize it. You always have to do this, as long as you remember that if you call this one lambda 1, and that becomes X prime, and this one lambda 2, that becomes Y prime. If you do it the other way, when you calculate the angle, remember that's from your defined X prime to the original X, and that's from your original, the Y prime, your defined Y prime to the original Y. So here we found this. Now this result, of course, depends on the angles. It's related to the angles we choose. So from here to here is just mathematics, right? Okay, now let's find step 2. So how do we find the angles? The angles are determined this way. Once you determine this IX and IYY, we do this. You're going to use this relationship. Use the following relation. So what is this relation? You're going to subtract, just choose one of them first. Let's take this one first, IX prime. And the original I is going to be 4, 2, 2, 2, correct? That's the original inertial tensor, which is determined by an arbitrarily selected coordinate system, or two-dimensional coordinate system. So you have this right here. Now, what we're going to do is we subtract this, just like the eigenvalue analysis. Now we're going to do this. We said for the diagonal terms, we're going to pick this one. 4 minus 0.764, just code 4. So save our time. It's code 4. Minus 0.764 for only the diagonal elements. Now this multiplied by what? By a vector. And this vector, the first element is cosine alpha. The second element is cosine beta. Then what happens if you do this? You just multiply the matrix times this vector, and the result must be a 0 vector, like this. So this is the condition for finding the angles, alpha and beta. Okay. Now, of course, it's the math is simple. So we just carry out this calculation for the first element, that becomes 3.236 to 1.236 times cosine alpha, cosine beta to be 0. Now, how do we carry out this? kind of matrix operation. I know that this is matrix operation. Some of you may heard about this from calculus or linear algebra or from other places. So here we will use two different conditions. The first zero is the product of the first row of this matrix times this column. So the first element of the row times the first element of the column.